Introduction.
Mother, what are you doing?
I'm stitching a pattern on your frock.
Can you stitch similar patterns on some more frocks of mine, Mother?
Why not? But I do not have enough buttons for those patterns. Will you buy them for me, Vanchika?
Definitely, Mother. How many would you need?
I will need 16 for one pattern.
I want patterns on 5 frocks, so I will buy 16 times 5, that is 80 buttons.
Concept of variable. Ananya creates dancing figures using triangles made of wood. One day she receives a request from her friend Rita for 10 such dancing figures. How many triangles will Ananya require to create them? Take a careful look at the dancing figure. Ananya uses 9 triangles to create it. Therefore, in 10 dancing figures, Ananya will use 9 into 10 is equal to 90 triangles. Rita's aunt notices the dancing figures and likes them so much that she orders 50 such pieces. How many triangles will Ananya use in these 50 dancing figures? Ananya uses 9 triangles in one figure. Therefore, in 50 figures, Ananya will use 9 into 50 is equal to 450. Ananya will use 450 triangles in 50 dancing figures. The triangles Ananya uses in a single dancing figure are fixed. However, the total number of triangles used by her varies, depending upon the number of dancing figures she makes. We can, therefore, generalize by saying, if Ananya makes n dancing figures, she will require 9 into n triangles. Algebra. Algebra is a division of mathematics which represents numbers with letters of the alphabet. The letters are replaced by different numbers to obtain different answers. Therefore, as the letters assume varying numeric values, they are called variables. Let us look at some more real-life situations in which algebra is used. Raju cleans cars in a housing society. For every car he cleans, he charges 200 rupees. Express Raju's total earnings in terms of a variable. Raju's total earnings depend on the number of cars he cleans. Suppose he cleans n cars. Raju's cleaning charges for one car is 200 rupees. Raju's cleaning charges for n cars is equal to 200 into n. Therefore, Raju's total earnings are 200 n rupees. Riya is 5 years old now. Express her age 10 years from now. Generalize the expression with a variable. Riya's present age is 5. Riya's age after 10 years is 5 plus 10. Riya's age m years, hence 5 plus m. Therefore, m years from now, Riya will be 5 plus m years old.
By using mathematics, you can form the different alphabets. Okay, alphabetic letters. Here is one example. Here, let alphabet the L. Letter alphabet letter L. L is formed using mathematics. Okay, here is one L is there. Is how many mathematics? Is one L, 2 mathematics required. Here 2 L's are there. How many mathematics? 1, 2, 3, 4 mathematics. Okay. Then here how many mathematics? Is 6 mathematics required. Okay. Here like that you have to make a 4 L's, 5 L's. Arrange it in form of a table. Okay. Here number of L's formed. Here 1 L. 1 L how many mathematics? Number of mathematics is 2 mathematics required. Then 2 L's is 4 mathematics. Then 3 L's how many? 4 L's how many mathematics? Is here 3 2's are 6. Here 2 2's are 4. 2 multiplied by 1, 2. So here 4 2's are 8 matchsticks. Here is 5, else is 10 matchsticks. So how you write it in, generally how you write it in algebra, using algebra or variable? Number of matchsticks required equals the number of L is changing. Here 1 L, here 2 L's, here 3 L's, here 4 L's. Then here 1 it's a multiple of 2. Here 2 it's also multiple of 2. Okay, here is number of L's formed is changing, so it represents a variable n. Okay, variable n. Then how you write is 2n, 2 multiplied by n. 1L, if n is 1, then 2 into 1, 2 matchsticks. If n is 2, 2 into 2, 4 matchsticks. If n is 3, 3 into 2, 6 matchsticks. Then if n is 4, then 8 matchsticks. Like that. Hope all of you understood. Like that you are trying to make the letter C. Okay. Here how many matchsticks? 1, 2, 3 matchsticks. For 1C, 3 matchsticks. Okay. Then for 2C's how many matchsticks? 1, 2, 3, 4, 5, 6 matchsticks. For 3C's how many matchsticks? 1, 2, 3, 4, 5, 6, 7, 8, 9 matchsticks. Okay. You have to arrange it in a form of table. Number of C's formed 1C. How many matchsticks? 3 matchsticks. Okay. 2C's. How many matchsticks? Is 6 matchsticks. Okay. Then 3C's. How many matchsticks? Is 9 matchsticks. Here is 1 multiplied by 3, 3. 2 multiplied by 3 is 6. 3 multiplied by 3, 9. Then 4C's. How many matchsticks? Is 4 multiplied by 3, 12 matchsticks. 5C's. How many matchsticks? Is 5 3's are 15 matchsticks. Like that, here is number of C's formed is changing. So all are multiple of 3. Okay. Then how you represent number of matchsticks? Number of matchsticks required equals, here is number of C's formed is changing. Take the variable as x. Okay, then how is 3 multiples of 3. Okay, 3x. Number of matchsticks required equals 3x. 3x is the number of matchsticks required. It's in algebraically. Okay. Here x represents the number of C's formed. If s is 1, 3 multiplied by 1, 3. If x is 2, 2 multiplied by 3, 6. If x is 3, 3 multiplied by 3, 9. If x is 4, 4 multiplied by 3, 12. If x is 5, 5 multiplied by 3, 50. Hope all of you understood. Exercise 11.1. Here one question. Cadets are marching in a parade. There are 5 cadets in a row. What is the rule which gives the number of cadets given the number of rows? Here is 1 row. How many? Is 5 cadets. Then 2 rows. How many total? 5 plus 5, 10. Then 3 rows is 5 plus 5 plus 5, 15. So they are multiples of 5. Okay. First row is 5 cadets. Then have you arrange it using, express it using variable. The number of rows be in. Take the number of rows be in. Okay. What is the rule which gives the number of cadets given the number of rows? Here is you have to find the number of cadets. Here the number of rows be in. Okay. How you find the number of cadets? It's number of cadets. Number of cadets equals is, here for first row is 5 multiplied by 1, 5. Okay. First row 5 multiplied by 1, 5. carats. Then 4 is 2 rows. For 2 rows is 5 multiplied by 2, 10 carats. Okay. For 3 rows, 5 multiplied by 3, 15 carats. For 4 rows is 5 multiplied by 4 equals 20 carats. Okay. Here is how is the general formula. N represents the number of rows. Okay. 5 multiplied n, you can write it as 5n. Okay, hope all of you understood. The next question, if there are 50 mangoes in a box, how will you write the total number of mangoes in terms of the number of boxes? You have to find the number of mangoes and in terms of the number of boxes. So then here is number of boxes be there. Have to take number of boxes be small letter b. Let the number of boxes be small letter b. Okay. Let the number of boxes be small letter p. Okay, use the variable small letter p. Then you have to find the number of mangoes. Number of mangoes equals here is for one box 50 multiplied by 1, 50 mangoes. For 2 boxes 50 multiplied by 2 is 100 mangoes. For 3 boxes 50 multiplied by 3 is 5 3s are 15, 150. Okay, that goes on. So here is number of boxes represents the letter b or variable b. And how you write is 50 multiplied by b, or you can write it as 50b without the multiplication sign. Okay. Then next question. Leela is Radha's younger sister. Leela is 4 years younger than Radha. Can you write Leela's age in terms of Radha's age? Let Radha's age be x years. Then how you find the Leela's age is Leela is 4 years younger than this Radha. Then how you write is x plus 4. Okay, x plus 4 years younger. Okay, x plus 4. How all of you understood?
Arithmetic properties and variables. Let us now express some commonly used arithmetic properties with the help of variables. These properties are commutative property, associative property, distributive property. Let's take a brief look on each point. Commutative property. Addition and multiplication of two numbers are commutative. In other words, a change in the order of the two numbers added or multiplied does not affect their sum or product. 9 plus 8 is the same as 8 plus 9. 5 into 6 is the same as 6 into 5. The commutative property holds true for all numbers. We can therefore generalize it with variables as a plus b is equal to b plus a into b is equal to b into a. Associative property. Addition and multiplication of three numbers are associative. In other words, a change in the order of the three numbers added or multiplied does not affect their sum or product. 9 plus 8 in brackets plus 7 is the same as 9 plus 8 plus 7 in brackets. 5 into 6 in brackets into 4 is the same as 5 into 6 into 4 in brackets. Associative property holds true for all numbers. We can therefore generalize it with variables as bracket starts a plus b bracket closes plus c is equal to a plus bracket starts b plus c bracket closes. Bracket starts a into b bracket closes into c is equal to a into bracket starts b into c bracket closes. Distributive property. Look at this expression. 5 into bracket starts 8 plus 9 bracket closes. It can also be written as 5 into 8 plus 5 into 9. This property is known as distributivity of multiplication over addition. It holds true for all numbers. We can therefore generalize it with variables as bracket starts a plus b bracket closes into c is equal to a into c plus b into c. Geometric concepts and variables. The concept of variables can be extended to geometry. For example, diameter of a circle is twice its radius. It can be expressed as diameter is equal to 2 into radius or d is equal to 2 into r, where both d and r are variables. As r changes, d also changes. Let us use variables to express perimeters and areas. Perimeters. Perimeter of any two-dimensional figure is the length of its boundary. Perimeter of rectangle ABCD is equal to AB plus CB plus DC plus DA. Opposite sides of a rectangle are equal. Therefore, DC is equal to AB is equal to L for length. DA is equal to CB is equal to B for breadth. If perimeter is represented by the variable P, then P is equal to L plus B plus L plus B is equal to 2L plus 2B is equal to 2 bracket starts L plus B bracket closes. Variable P varies with variations in the variables L and B. Perimeter of square. ABCD is equal to AB plus CB plus DC plus DA. All the sides of a square are equal. AB is equal to CB is equal to DC is equal to DA is equal to S for side. If perimeter is represented by the variable P, then P is equal to S plus S plus S plus S is equal to 4S. Variable P varies with variations in the variable S. Areas. Area of rectangle ABCD is equal to length into breadth. If area is represented by variable A, length by L and breadth by B, then A is equal to L into B. Variable A varies with variations in the variable L and B. Area of square ABCD is equal to side into side. If area is represented by variable A and side by S, then A is equal to S into S. Variable A varies with variations in the variable S.
Exercise 11.2. Here on that problem. The side of an equilateral triangle is shown by L. Small letter L. So here L is the variable. Okay. Express the perimeter of the equilateral triangle using L. We have to express the perimeter of equilateral triangle using the alphabet or variable L. Okay. What's the formula for perimeter of equilateral triangle? Perimeter of the equilateral triangle equals equilateral triangle equals how much is 3 multiplied by is length of one side. Length of one side. Here is length of side of an equilateral triangle is shown by is L. Yes, how to write 3 multiplied by L. Perimeter of the equilateral triangle is 3 multiplied by L. Then next, the side of a regular hexagon is denoted by L. Express the perimeter of the hexagon using L. Hexagon is the figure. How many sides? Is 1, 2, 3, 4, 5, 6 sides. Hexagon has 6 sides. How we find the perimeter for hexagon? It's 6 multiplied by length of 1. Perimeter of hexagon Regular hexagon. Okay. Regular hexagon. Regular hexagon has all its sides and angles equal. Hexagon equals 6 multiplied by length of one side. Here is length of one side is represented using L. 6 multiplied by L. The next question. A cube is a three-dimensional figure. It has 6 faces and all of them are identical squares. The length of an edge of the cube is given by L. Find the formula for the total length of the edges of a cube. Okay. Here is cube. How many sides? This is 6 faces. 6 faces. How many faces? 6 faces. All its faces are identical and length of an edge is shown by is L. How you find the total length of the edge? Is total length of the edges of a cube equals the length of the edges of a cube equals is how many edges? Is 12 edges. So length of one edge is L and total how many edges? It's 12 multiplied by L. Okay, total length of the edges of a cube equals is 12 L.